Welcome to The Explainer. Today, we are stepping right onto the tarmac for a real pilot's eye view of a pretty incredible aircraft, the Diamond DA42. We're going to get into all the details that pilots need to know, from the very materials it's built from, all the way to how it handles the unexpected.
Okay, so let's get right into it. What makes the Diamond DA42 so special? Well, it really starts with its skin. You see, unlike most planes you see, which are made of aluminum, this one is built almost entirely from advanced composites. And that's not just to make it look cool, it's a fundamental design choice that gives it incredible strength while keeping it super light. And that, right there, is the secret to its amazing performance and efficiency.
So here's how we're going to tackle this, just like a pilot's pre-flight briefing. First, we'll do a walk-around, checking out the airframe. Then we'll jump inside that amazing glass cockpit. After that, we'll look under the hood at the engines and fuel systems, crunch some real-world performance numbers, and finally, we'll cover what to do when things don't go exactly as planned.
All right, first up, let's really dig into the airframe itself. The way the DA42 is built is a huge part of its story. It's not just about looking futuristic. These materials really define what this plane can do.
So check this out. Composites are everywhere on this plane. The main body, the fuselage, and that really distinctive T-tail are made from something called glass fiber reinforced plastic, or GFRP. But look at the flaps. They use a composite sandwich of both that glass fiber and the even stronger carbon fiber reinforced plastic. Why? Well, flaps take a beating during takeoff and landing, so you need that extra strength right where it matters most.
Now, this leads to a really important safety philosophy that's literally built into the DA42's wings. Inside each wing, there are two main support beams, called spars. This is that fail-safe concept in action. It's all about redundancy. It means that if one of those spars were ever damaged, the other one is designed to handle the full load, giving the pilot a massive margin of safety.
You know, the way you actually fly this thing is a fascinating mix of old school and new tech. For the ailerons and the elevator, the things that control roll and pitch, the DA42 uses solid, rigid push rods. That gives the pilot a really crisp, direct, and responsive feel. But for the rudder, which controls that side-to-side yaw, it uses a more traditional system of flexible steel cables. It's a cool combination that gives you precision where you need it most.
All right, let's climb into the pilot seat. And now we get to talk about the aircraft's brain, its advanced cockpit systems. We're talking about the Garmin G1000, which isn't just a GPS. It's a whole suite of electronic displays that gives the pilot an unbelievable amount of information.
The G1000 basically talks to the pilot using a simple color code. Green means go, everything's good. White is just a little heads up, an advisory. But a pilot's training is laser focused on those top two, amber cautions and red warnings. And knowing the difference isn't just academic, it's absolutely critical.
So let's break that down. A red warning is the plane basically screaming for help. It's a continuous, loud alert with a flashing red light, and it means you need to do something right now. An amber caution, on the other hand, is way more subtle. It's just a quick 1.5-second chime with a flashing amber light. It's the plane's way of tapping you on the shoulder and saying, hey, you should probably take a look at this when you get a second.
Just 6 to 10 seconds, that's it. That's how fast the hydraulic landing gear extends and locks solidly into place. It's a quick, reliable system. But because it's so important, the plane has some pretty clever tricks up its sleeve to make sure the pilot never, ever forgets to put it down.
The aircraft is smart. It's basically designed to save you from yourself. A loud warning horn will go off if you start pulling the power back to land. That's the manifold pressure dropping. Or if you put the landing flaps down but the gear is still up. It's another one of those critical safety nets that's just built right into the system.
Okay, let's talk about the heart of this machine. It's two engines. And having two isn't just about going faster. It's about redundancy, which is a massive safety advantage. So let's take a look at these power plants and all the systems that keep them fed and running smoothly. Each of the DA42's engines is a solid 180 horsepower, 4-cylinder workhorse. They're controlled with that classic 3-lever setup, black for throttle, blue for the propeller RPM, and red for the fuel mixture. But honestly, the most critical safety feature here is kind of hidden. The ignition system uses magnetos, which are totally independent of the plane's main electrical system. That means even if you had a complete electrical failure, the engines would just keep on running. That is huge.
Think of this as your insurance policy for the fuel system. Now, each engine has its own main mechanical fuel pump, but this electric backup pump is always turned on for takeoffs and landings. You know, the most critical parts of any flight. It's there to guarantee you have consistent fuel flow when you absolutely need it the most.
This right here is the aircraft's central nervous system. This 28-volt system, which is powered by a big 70-amp alternator and has a battery backup, runs literally everything, from the landing gear pump and the flaps to those beautiful bright displays in the cockpit.
So we've got an advanced airframe and super reliable engines. What does all that mean when the rubber meets the runway? Let's see how this all translates into real-world performance. For a pilot, knowing these numbers by heart is everything.
14 knots. That is the maximum demonstrated crosswind this aircraft can handle for takeoff or landing. To put that in perspective, that's a pretty stiff breeze of about 16 miles per hour blowing straight across the runway. It's a hard limit that pilots absolutely have to respect.
This chart really shows you that not all runways are created equal. Taking off from a field with just a couple inches of grass, you're going to need 10% more runway. A gentle 2% uphill slope, that's another 10%. And here's the kicker. These penalties add up. They stack, and pilots have to calculate for them before every single takeoff.
There's a reason pilots will always choose to take off into the wind if they can, and this is the cold, hard math behind it. A headwind helps lift the plane off the ground sooner, but a tailwind is an absolute performance killer. Just a tiny 2-knot bush from behind increases the runway you need by a massive 5%.
You know, a great aircraft isn't just about how it performs on a perfect day. It's also about how it helps the pilot manage when things don't go as planned. So let's look at a couple of those what-if scenarios.
Flaps are a huge deal. They change the shape of the wing to give you more lift and more drag, which lets you fly a nice, slow, stable approach to landing. So what do you do if they get stuck?
Well, the good news is the procedures are clear and very manageable. If the flaps are stuck up or just in that first approach setting, the answer is the same. You just fly your final approach a bit faster, at a minimum of 85 knots. Now, you'll need a longer runway to land, but it's a perfectly safe and predictable maneuver. And if they happen to be stuck all the way down, even simpler. Just land normally.
And here's one for a more traumatic situation. A lightning strike could cause damage you can't see. So to ensure the plane's structure is okay, the procedure is to immediately slow down to 126 knots or less. This reduces the aerodynamic stress on the entire airframe until you can get the plane on the ground safely for a full inspection.
So from its fail-safe composite wings and its redundant engine systems to the smart cockpit alerts that are designed to prevent simple mistakes, the Diamond DA42 is just a masterclass in thoughtful, safety-first engineering. So after seeing all that, what part stands out to you? Was it the materials, the electronics, the performance numbers? That's our explainer for today.